We humans are creatures of the surface. We drown if you leave us in water too long. We freeze or asphyxiate if you shoot us 10 kilometers up into the atmosphere. To survive in those environments, we need specially constructed containers, a bit like this cable car that I'm riding up to Seoul Tower, but much fancier, more like submarines or planes or even spacesuits. Many organisms are much hardier than us. Some microorganisms and migratory birds can live, at least temporarily, in the thin and icy air in which international jets cruise. The oceans have been home to life since life first appeared. Today, sperm whales can dive up to 2 kilometers below the surface, but 10 kilometers below the surface you can find much stranger organisms, some of them feasting off the carcasses of dead whales, some of them using the chemicals and the boiling water that comes out of deep sea oceanic vents. The soil beneath our feet is full of organisms, and we now know that some of them may live up to 6 or 7 kilometers below the surface. Still, most of life can be found in a thin envelope near the surface that we call the biosphere. This is life's comfort zone. It's a very thin and fragile layer, and it's had an exciting and sometimes dangerous history. Life, it turns out, has been very vulnerable, in fact the entire biosphere, to sudden changes, and sometimes these have generated mass extinction events when up to 50% of all species have died. Between 2 and 3 billion years ago, photosynthesizers began to raise the amount of oxygen in the oceans and the atmosphere. For most organisms at the time, oxygen was poisonous, so they perished in huge numbers in what today we call the oxygen holocaust. But the fossil record shows that in just the last 600 million years, there may have been 5 mass extinction events. By far the worst was the Permian event, about 250 million years ago, in which up to 96% of all species on Earth may have perished in 2 separate catastrophes about 10 million years apart. That was a pretty close shave for life on Earth. So here's the question. What are the main factors that have shaped the history of the biosphere? It turns out that astronomical, geological, and biological forces have all played a role in the history of the biosphere. What astronomical factors affected the history of the biosphere? Perhaps the most important was the relationship between the Earth and the Sun, which is the main source of energy and light for all organisms on Earth. To avoid sharp temperature fluctuations, a habitable planet needs to have a fairly stable orbit. Now, in fact, the Earth's orbit is constantly changing, partly as a result of changes in the shape of the orbit, partly as a result of changes in its axis of rotation. These changes are known as Milankovitch cycles after the scientist who first analyzed them. And what they mean is that the temperature at the surface of the Earth is constantly changing, but fortunately for us, those changes are not sufficient to make the planet uninhabitable or to affect the biosphere. The speed of rotation of a planet also matters. If it rotates too slowly, one side gets barbecued and the other is frozen. Its size also matters. If a planet's too small, it can't hold a large enough atmosphere because there's not enough gravitational pull. If it's too large, it may hold such a large atmosphere that sunlight can't penetrate to the surface. And what's more, all of these conditions must remain stable over many billions of years. Otherwise, what you might get is a planet that has a sort of flourishing of prokaryotes that then go extinct before any complex life forms appear. In fact, that might have been the fate of Mars. Asteroids can also have a huge impact on the biosphere. Walter Alvarez showed that the mass extinction that wiped out the dinosaurs about 65 million years ago was probably caused by the arrival of an asteroid about 12 kilometers wide that landed off the coast of modern Mexico. The result would have been like a nuclear war. It would have kicked up a huge dust cloud that would have blocked off sunlight and prevented photosynthesis and food production for perhaps several years. The dinosaurs were particularly vulnerable because they were large, so they needed lots of food, and they reproduced slowly. So it was very bad news for them, but it was great news for our mammal ancestors who flourished in a world free of dinosaurs. Now, as a mammal, think about this. If that asteroid had been on a trajectory half an hour earlier or half an hour later, it would have missed the Earth, the dinosaurs would still be here, and you and I wouldn't be here. And if that asteroid had been bigger, it might have wiped out all life on Earth. How did geological factors affect the history of the biosphere? Periodically, it seems that large movements of tectonic plates may have caused massive volcanic eruptions that released huge amounts of the greenhouse gases, methane and carbon dioxide into the atmosphere and reduced the amount of atmospheric oxygen. Now, the result of this would have been a sudden, perhaps catastrophic global warming. It's possible that the Permian extinction event 250 million years ago was caused by a change like this. The exact configuration of the continents can also make a huge difference to global climates and to the history of life on Earth. For example, today the fact that a large continent, Antarctica, sits over the South Pole explains the existence of huge southern ice sheets, while the arrangement of the northern continents blocks off the flow of warm tropical currents to the North Pole. Taken together, these arrangements explain why today we live in an era of ice ages. But occasionally it seems that global temperatures have plummeted much lower than this during so-called snowball Earth events. During these events, kilometre-thick glaciers may have covered much of the Earth and threatened the very existence of the biosphere. It seems likely that one possible cause of these was an arrangement of the continents that caused massive rainfall, which sucked huge amounts of carbon dioxide out of the atmosphere and led to sudden, sharp falls in global temperatures. The end of the last of these snowball Earth events, perhaps a little over 500 million years ago, may explain the sudden proliferation and diversification of life on Earth that we call the Cambrian explosion. How has life itself affected the biosphere? Well, one way is by changing atmospheres. We've already seen how early photosynthesizers pumped oxygen into the atmosphere and pulled out huge amounts of carbon dioxide. By doing so, they caused the oxygen holocaust, which wiped out many early species, but it also made possible the evolution of eukaryotes, our ancestors. Some species take carbon out of the atmosphere to make shells, and when they die, they sink to the bottom of the ocean, and over millions of years, they bury that carbon in huge sheets of sedimentary rocks, such as limestones or chalk. And in fact, if you look at a piece of natural chalk through a magnifying glass, you may see some of those organisms. In this way, tiny creatures could transform geology by creating entire new geological strata. Other organisms also bury carbon. And today, we humans are uncovering their remains in the form of coal, oil, and natural gas, the so-called fossil fuels. By burning them, we're returning that carbon dioxide into the atmosphere at an incredible rate. We know that the biosphere is fragile and small. And we also know that it's constantly under siege from a whole range of astronomical, geological, and biological factors. Yet so far, knock on wood, though many species have gone extinct, life as a whole has survived for almost 4 billion years. What we don't know is how the biosphere will change in the future. And in particular, we don't know the role that our species, Homo sapiens, will play in that story.